Hooray. Okay, so last time we implemented parsing a single function and then calling the main function by using our function eval function. And our job for today is to extend the parser to parse not just one function, but many functions, and then to extend the interpreter to be actually able to do function calls, which we also have to parse, but that's going to be pretty easy. And at that point, we're done. The interpreter is complete. So let's look first at the interface that we're going to use. We already put in the we extended the data structure. Well, the data structure didn't actually need extending because we had. Oh wait, no, that's bullshit. We can't use this. We can't use recur to also handle calls, because for calls we also need to know the name of the function that is called, right? So I totally made a mistake. So we do actually need a separate call which has the name of the function and then the arguments.
Name it call.
And I'll name it call. And we have the call expression type. And then we extended the function type to just be a linked list. So could I have used the din arrays? Yeah, I could, but I'm lazy. We'll just use the linked list. And then we might want to we'll talk about the interpreter later, because the interpreter will have to have access to the list of functions so that it can call a function whenever the parse tree says to call a function. But we'll do that later. So let's go to our parser first. And so the other thing is that we're gonna write a parse program function, which also, funnily enough, returns a function t-pointer, but in this case, it's not just one, but it's a list of functions. And the parse function thing here, we should initialize function next to null, just to make sure that we don't have any weird pointers from nowhere. So now we're going to parse a program, and a program is, as the as the syntax says, just a sequence of functions containing at least one. So what we're going to do is we need to parse a function from the context, and then we need to, while we are not, actually, if we can do it like this, do parse function while the look ahead dot type is not token eof. Right? And now the only thing we need to do is we need to collect the functions in a list. And does the order in the list matter?
If we do it like in C, yes, but otherwise not.
Like in C, meaning what?
Well, I think in C was if the I don't know exactly how C does it, but you know, if you do it in the wrong order, then C doesn't know that the function already exists when it tries to parse it. I think.
Yes, but we are not really concerned with producing error messages if the function is not known. We're mainly concerned with executing correct programs.
Yeah.
So I think I actually say in the README, that control constructs, values, operators, syntax, function names for. Oh, do I not? I thought I had that somewhere. Okay. Functions can only be used in their own definitions or in later definitions. So in that sense, it kind of is like C. But again, I'm not going to write a checker for that, right? I'm only concerned with calling the correct function. And I should actually, so the only thing in which it might matter in any way, shape, or form is if it were possible to define the two functions with the same name and then have kind of like some overload resolution in which the order matters, right? But if all I want to do is find the function with that name in the list, then it doesn't matter what the order is in the list because there's only going to be one. Does that make sense?
Yeah, that makes sense.
So I'm going to specify that no two functions with the same name are allowed. All functions must have different names. Is that better? Okay, so that means, and the reason why I asked that is because it's easier to build up a linked list in reverse. Right, all I need to do is, I'm going to say this is the list of functions, and this is a new function.
The stream is like frozen on my side. I don't know.
Oh,
Felix,
do you see my stream? Do you see stuff happening, Felix?
Mm-hmm.
Okay.
So the last line you have is the func.net next.
Yeah, you see me typing, right?
Yeah.
So I'm just building up the lists. Nothing interesting to see here. And I'm returning the list. Is that correct?
Mm-hmm.
I'm just parsing a function. I'm prepending it to the list, and I return the list of functions. So that's cool. I'm also going to write a quick printer for that. Scan main, print expr, print function. I'm going to call it static void print program. This is going to I know this is going to cause me trouble later on if I use the same type for functions and for programs. It's not a good idea. So I'm going to make a new type. Def struct program key. And this has a list of functions. Function key, functions. Parse program. So print program prog, and then the parser. How do I alloc expr pool alloc program t prog equals pool alloc size of program t prog functions equals list return prog. Okay. And all I need to do here, as far as I can tell, is function t func for func equals prog functions as long as func is not null, func equals func next unprint function func. Right? Except that now it comes crashing down in my head because I want this to print in the right order. I don't want this to print in reverse order. Well, sucks to be me. So I still have to do it. I'm going to show you a trick. A trick
Why
that
did you declare the func outside of the floater? I'm just curious.
Oh, that's just me being old-fashioned. That was, I think, a C. That was not in
It's like a
C89.
C89,
It's like an old whatever. Okay, so this will print in reverse order. Parse function main. Let's call it parse program main. Parse function main, parse program main. Program t prog and program prog. So this should now, well, first of all, it should compile. Prog functions func equals func next what? From struct function. Oh, did I?
The type is struct function?
Oh, see, this is a bug. Unused function, okay. So theoretically, I should be able to use anything that's in the examples now, like I don't know, bit set maybe. If I do simplang examples bitset.sl. Oh, interesting. T.type equals type. Okay, that's interesting. Let's see what happens. Oh no, I still haven't fixed my GDB. Okay.
So when you change that recurring call thing, is that's with the parser?
When I change the recur, no, because I'm not using the expect token end. Oh, that's interesting. P function. So I've been parsing the function main. Is there a bug? Examples bitset SL. Oh, of course. I can't parse this yet. I can't parse the call yet. That's why I get a parse error. So it's just confabulating bullshit, and then at some point it can't parse it. Okay. So we're missing that. Token recur. And I should take that out of here. We still need to parse the calls too. And I will parse that in the same rule because they basically look the same. Token recur, case token call. Okay. So the difference being that if what is it? T.type equals token call, then I have to have a function name, right? So I'm gonna say name equals null, and here I'm gonna say name equals T dot, what is it? Ident? T dot name, T dot something, T dot B dot name. So in the case of a recur, the name is null, and if it's a function, then we have a name, right?
Mm-hmm.
And now all I need to do is if the name is null, we make a recur expression, else we make a call expression. And this is the same, but we also have a name, and the name is name. Good?
Okay.
Okay. So then we still need to print it. How did I specify how to print a call in the assignments? No, I did not. So let's invent something. Let's invent, well, wait, where is the recur? Where do we print recur? Loop recur X. How about we use the same thing except that here we just print the name of the function. It should be unambiguous because the name of the function cannot be a reserved word, right? So it can't be recur, for example. So let's write a very simple example like temp add.sl buffer, yes, let add ab equals, no, let, yeah, let, yeah, a plus b, and let main a b be add a b, and so we should now be able to parse this if our compiler interpreter parser compiles. No, did you mean? Oh, of course not. It's not a. Oh no, I forgot everything.
Okay, I did.
Yeah, no, but we can't do it here. We have to. We already have a case for the token ident, right? And as I said last time, we need to distinguish a lone identifier from a call by whether the identifier is followed by an open paren, which signifies that the argument. Do you remember? Okay. So basically, this case is both of these cases. And what needs to happen is if the look ahead equals token open paren, then I need to parse a function. Otherwise, it is a sole identifier. Okay. That means that all of this goes out the door. And the name is actually a b.name. And also, we're going to make a function that parses args. And that function is all of this. Static in RT args. Okay, we're getting there slowly but surely. So we're in RTR, we're initting the dynamic array. We're parsing the arguments. This here, there's no call. This is bullshit. And instead, we still have the recur. And it's actually simpler now because we have a nice function for that. We need the code that I deleted here. And nRT r equals parse args. The context, and now it should work. Yes?
Maybe.
You're getting increasingly skeptical. Okay, so that looks good. The function main calls bitset, and this is bitset. But main should come afterwards, right? When we're printing, we want the correct order. So we might as well put the correct order in the list. So let's do that. Okay, so here comes a trick. The one way to build a linked list from front to back is by keeping a pointer, function t last, by keeping a pointer to the last element and then appending to that element, right? So I could say, if I have a last element, right? If last is not null, then I'm going to say last next equals func. And then I'm going to say last equals func. But also I need to say list equals func. So list equals last equals func. This happens when I don't have an element yet. So the list is empty, there's no elements. Then, oh, no, I'm sorry.
That's when you do have it.
That's when I do have an element. Right? I should do the other case first. If I don't have an element yet, then list equals last equals func. And this is my one and only element. It's the first element and it's the last element, right? Otherwise, I do have a last element, and so I append func to the last element, and func now is my last element. Does that make sense? Felix?
Wait, I'm thinking. No,
I
yeah,
see.
that makes sense.
Okay, so let's try it out.
But wouldn't we have to initialize or? Oh no, we don't have to initialize list every time, right? Just the first time.
Yeah.
Last as
Because
well.
it's the
Okay.
first element,
Okay,
right?
right.
And the first element doesn't change. I mean, once I have a first element, it stays the first element.
Yeah.
I should call it first. First. Now here's a trick that you probably shouldn't do, but it's kind of cute, so I'm going to show it to you. I can do without this branch if I keep a pointer not to the last element, the pointer that points to the last element.
Whoa.
Which in this case is first. And when I append, and when I pre-append, what I do is that pointer to the last element is assigned the new element, and it becomes the next pointer of that element. Does that make sense?
Also, we set the
So
pointer.
imagine. Come again.
Wait, sorry.
No, come again. What did you say?
So we basically just initialize like the space where the first pointer is pointing at by saying it should take the space from from P to last. Oh jeez. Okay, no, sorry, you go. I'm way too deep into this.
Okay, so this is the pointer first, right? Which at the beginning points to null. And P to last points to this pointer. And P to last will always point to whichever points to where I need to append the next element. Or the pointer which I need to modify to append the next element. Right? So now if I allocate a new list element, this is something, blah, 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 and then it's next. Next itself is a pointer, right? Mm-hmm. So what I'm doing is, by assigning to star P to last is first, right? So I'm just saying, okay, first point to this thing, right? So first is now pointing to this thing. And then I say, make P to last point to the next pointer within this thing, right?
Oh, geez.
So I'm saying P to last, please point inside here. Point to this next thing. And now if I allocate a new one, here it comes a new one, yet another one, which also has a next pointer. Now when I assign to star P to last is the same as the next pointer inside this one. right? So I'm modifying the next pointer here to essentially point to, well, I should maybe, I don't know. I'm modifying this to point to this thing. Right?
That is cool. Whoa.
But again, you shouldn't do it because it's
Oh, no,
easy
no.
to get.
I
It's
will,
easy to
I
get.
will do it. I will do it
Okay.
from now on.
As you can see, it still works. But I will go back to the old code, because you shouldn't do this.
No. No, man.
It's just not worth the headache of when you get it wrong.
Yeah.
Okay. So now we have this. I'm going to put this into the documentation here, assignments. But let's say example input, add. Then output. Okay. Now we have this. And I should make a test case. Tests. This is parser 1.13, copy temp. Well, I can actually just make it, no, I can't. Copy temp add.sl, parser 1.13, cat to parser 1.13. Okay. And I should commit this. Parser, main function, and the compiler. And why not the read? Well, this part at least. And the assignment. And 1.13. So now, the one thing that we're missing is we don't know how to actually interpret a function call. We do know how to call a function if we have the function. But how do we get the function is another question. In particular, if we are in the interpreter here in eval expert, eval whatever, we don't have access to any function. So what we need is, we unfortunately need to pass in yet another stupid argument, that argument being the program. So I'm going to put that as I'm going to put it as the first argument. Program. And I'm going to eval expr. Yeah. And I need to parse it in, pass it in here. And actually, it turns out here too. But I'm going to call it prog. So now when I come to an expr call, actually, again, I have pretty much, no, this is different. Do it differently. Because here I'm making the environment. I'm not going to make an environment. I just need an array. If you look at this here, I just need an array of integers. And I can actually declare this on the stack. I can say args of expr b call n. And now I can iterate over the arguments. And all I need to do is in args of I equals eval expr, well, prog expr b call args of I. Yeah, and that's pretty much it. But then I need to call the function. So I'm just going to posit a function that is going to be called call function as opposed to eval function, which again takes the program and it takes the name of the function and it takes the arguments. And what that is going to do, obviously, it's going to search for the function of that name in my list of functions, and then it's going to call eval function on that. I'm going to write that real quick. Where do I have eval function? Oh, I have it down there. But I do have it declared, so I'm just going to put it in, I don't know, here. Now, here's the thing. Will call function return an int p result t, or will it return an int64 t? That was a question to you, Felix Architect.
Int64.
And why is that?
Because we are, I thought we're evaluating the program, basically.
We're evaluating. We're calling a function.
Okay.
It's because it needs to be able to be within like other expressions. Actually,
why did we need this in the first? What was this for?
That's what I'm trying to remember.
This was for the recur. This was to distinguish whether we're actually returning a value or whether we need to recur.
Okay, so can we say that? Oh, geez.
Well, the recur can't happen. I mean, the function can't return a recur, can it?
Yeah, no.
It's not.
You can't recur. You can't recur out of a function. That's not allowed.
Yeah. So then
a recur must always be within a loop statically. Right?
Mm-hmm.
You can't have a function that just recurs.
It's called a recur.
Does that make sense?
Yeah, that makes sense.
Yeah. Also eval function only returns an int64 t, so we couldn't even. I mean, we could make an int p result t out of the int64 that is returned, but there would be no point in that. Okay, so this is easy. Function t func for prog functions. Next, if the name of the function is the same as that name, then we have found our function, and we're going to call it return eval function. We're going to pass the program, we're going to pass the function, and we're going to pass the args. And that's actually all there is to it. And here we just need to say assert 0, meaning that we call the function that doesn't exist. That was easy. Now, we're missing one last thing, which is everywhere we call eval, we need to pass the stupid program. Eve of env bind eval. Function prog. Oh, yeah, and eval function also takes a program because it needs to call eval. And then in the driver, we have to call it, we're going to have to call it eval. Yeah, we can just use eval main. That's fine. Eval function main. Why is there an eval main and an eval function main? Oh, yeah, never mind. Eval function main. Okay. Yeah, eval program main. So, program T program, and now actually it becomes useful to make this here externally usable, because I'm going to need it in my main thing. Because what I'm going to do is well, then I don't have the error messages. No, let's split it up. Let's call it function T lookup function. Program name. Lookup function. If return func, otherwise return null. And here I'm going to say function func equals lookup function. Program name assert func is not null. If it's null, then your function was not found, and we're going to evaluate the function. Okay. And this is still static. So now I can say function T function equals lookup function, namely in the program with oh yeah, main. That's the function I'm looking at. If function is null, then function main must be defined. And if it's the wrong number of arguments, then it's the wrong number of arguments. And here I'm allocating my arguments. I didn't even have to use pool alloc. I could have used the same trick as before to allocate it on the stack, but whatever. And then I evaluate the function, but I'm also passing in the program. And then I print the result. That should work. Okay. Sure. Whatever. But it's defined here too few arguments. Wait. Oh. In the environment, of course. I forgot the environment. Returning. Wait, why does call function return an int? Make int result. Program. Okay. So now, if I run simpling on temp add whatever, let's just use bitset. What does bitset do? You pass it a number and then the bit that you want to test. Is that it? The one bit should be set because 10 is 8 plus 2. Oh, look at that. This should not be set, but this should be set. All right.
Hey.
Seems to work. Let's do a more difficult one. Let's do next prime. Next prime.sl. What is the prime after 10? It's 11, 13, 13, 17, 100, 1,000, 10,000. Look at that. We have a compiler. Let's try.
What? Oh, okay. Is that okay?
Let's try the full test suite on Shani course Simplang. Some tests might be really slow
because there's no memorization. But
well, there you go. We have a full compiler. Interpreter. A very slow full interpreter. Congratulations to us. All right, any questions?
Not so far.
Was that hard?
I wish we wouldn't have done that in C, maybe. It's too late now.
Yeah. But you were able to follow along, right?
Yeah.
Yeah. It's just not, easily maintainable, and it's very easy to shoot yourself in the foot. But I'm actually pretty happy how it turned out. It wasn't too bad.
Yeah, looks good.
So the next thing is the virtual machine. Have you looked at the virtual machine?
No, I haven't.
Okay, then how about we're going to talk about the virtual machine and how the virtual machine works next time. And there's no assignment for next time other than reading the specifications of the virtual machine, and which is in vm.mb, and trying to understand it, and then we'll talk about it, and we'll talk about the first assignment.
Okay.
Cool?
Yeah, sure.
All right. How have you finished your interpreter, by the way?
The one from Monkey Language, not yours so far, but I'm close to done.
Oh, you're working just on Monkey now.
Yeah, no, I think for the virtual machine, I'd rather go with your language then.
Okay. Yeah. So how are you gonna do that? We have a few implementations. I have one. So basically, you will at least need a parser, a full parser, to continue working, which you could write on your own, or I have written one in C#, but Tay has written one in C#. I have one written in Python that a friend of mine wrote.
What about this? Like, can you not-
Yeah, you can also use the C one, but I don't know if you want to do that to yourself.
I don't know. I didn't think it would be that hard to finish it in Go.
Okay, sure.
I think I would be done by this weekend probably.
Yeah. All right. Good. But you are going to continue writing the Monkey interpreter.
Yeah. So
Okay.
in the book they do have, or the author has an interpreter for the Monkey language.
Yeah.
And yeah, just not the virtual machine.
So you're just following along, basically.
I'm just following along then, but
Okay.
yeah.
All right. Cool. Then talk to you next week.
Neat. Thank you very much.
Yeah. Bye.